Hello and welcome to my digital presentation of my audiovisual work, And You Shall Receive. My original concept was based around the concept of presence, and I wanted to explore three types of presence: physical presence, social presence, as well as digital presence. Social and physical presence were to be visualized with sound and video input, whereas digital would be captured via a computer. As social and physical presence has become more illegal in New South Wales, my focus has shifted more towards the legal digital presence. And You Shall Receive is a work that explores the presence of the digital, the millions of bits of information that surround us every day. If you know how to listen for it, you can hear the endless digital conversations happening between devices. And although you can hear this data, you cannot understand it through its encryption. And so we're forever doomed to exist in this digital flurry of the incomprehensible communications of others, without any meaningful way to understand what any device is saying. My work intends to visualize and interpret this noise in a constant and mesmerizing flow of information that is made tangible through projection and abstract sensory immersion. In my week 3 brief, I presented this space. The installation was to be an ambitious 2-projector, 3-monitor setup complete with surround sound audio as well as a Connect video input. Unfortunately, in the current circumstances, that sort of space doesn't seem to be possible. The equipment I have at home currently is limited to speakers and monitors, with 0 video input devices that seem to work. I'm designing this project with a floor and wall projection in mind, as well as a bird's eye webcam for blob tracking. By this point, it's looking like my final project isn't going to realize my initial ambitions. The key input behind my concept is live digital data flow. In the following couple of experiments within processing, I'll show how I've developed a processing file that can achieve live data flow, as well as the various ways in which I intend to display this data, both visually through processing and to a lesser extent using Minim sonically. So with experiment 1, I wanted to see from a technical standpoint if I was able to read from a file, translate that file into a visual stimulus, and then get a consistent stream of visuals from that file. You can probably see from looking at the sketch that it's pretty long and pretty gross looking, and one of the main problems I had with the experiment was actually just getting the strings and converting them into integers that I could actually use as visuals for the sketch. With this experiment, I was able to incorporate a little bit of sound, which is in the form of a repeating ticking sound file I found on the internet. But I wanted to, and I'm still sort of driving towards having only my own generated sounds from Minim and processing in my final project. I liked the visuals from experiment 1, but the simple printing out of data wasn't something I really wanted for my final project in terms of aesthetics. My next couple of experiments started on the basis that I was able to actually extract the data from Wireshark, and was focused more on how I would actually display the data. So the next 2 experiments are about inputting data into parametric equations in order to make visually appealing works. So experiment 2 isn't that long a script, but it did take a fair bit of tweaking to get looking somewhat nice. It's basically a plotting of 2 graph functions with a couple of lines plotted in between them. It was inspired by a work on polar equations done in the 70s, and I really liked the flowing sort of mesmerizing aesthetic that they arrived at. I'm a little bit disappointed with how mine ended up turning out. It was a lot more static than I would have liked, but I did manage to build on it with my later experiments to make something that was actually pretty visually pleasing. Experiment 3 is one that I had a lot of fun with myself. It's basically an iteration of the last experiment, but this time with user input and sound. The sketch reads from the same files as experimental 1, but this time it does so in a more abstract sense. The characters are displayed as points on two graphs which dynamically change both in terms of density and shape, which is based on mouse X and mouse Y. The text quickly overlaps and changes itself to the point where it's unreadable to the viewer, which I feel ties to my conceptual ideas pretty nicely. It's also the first experiment I've done which uses minim's instrument function, which took more work than I would have liked just to get a bit basic ticking sound, but I'm still proud of it. In the next coming weeks, I aim to work on my composing, but I don't exactly have high hopes. The final sketch I'll show isn't the most visually impressive, but it is fundamentally the most important part of my project. Experiment 4 is a proof of concept that I'm actually able to get live data from a network into a readable format into processing. One of the main drawbacks from using Wireshark is that in order to get a capture of network data into a processing sketch, I would manually need to enter Wireshark, start a capture, stop that capture after a couple of seconds, save the file, and then export the file all through a graphical interface. However, I managed to find a command line version of Wireshark called Tshark. With this version, I could run a capture for an allotted period of time with simply one line of code. I could then use a modified version of this code using process in processing to save that data capture as a text file within the processing sketch, which gave me a live data purely from my processing code. This was a massive step, but there was another problem. The one line of code that I just wrote takes the length of the capture time in order to execute, meaning if I wanted to capture data for 10 seconds, my processing sketch would stay frozen for that period of time. To overcome this, I made the sketch multi-threaded, meaning that two versions of the sketch would essentially be running at the same time. One that was frozen, capturing data, and the other one that was executing the draw function. This allows me to simultaneously be displaying and fetching data. This sketch is proof that in my final demo I'll be able to be working with live data, which is a property that will allow for my installation to actually interact with the digital conversations occurring within the space. Visually, all this sketch does is update every 4 seconds with the latest data it's captured from Tshark. An interesting point to note, however, is the variation in the amount of packets that are captured each time. This is an element that I want to explore both visually and sonically in my final work. In the next couple of weeks, my main focus is integrating sound in a more meaningful way. I'm confident that I'll be able to map live data into the sketch, and I'm also pretty confident in my ability to integrate a more involved input such as PoseNet or CV persistent blob tracking in place of mouse input. Like I said earlier, I plan on an installation with 2 projections and a webcam. However, my project can be scaled back potentially if that becomes impossible to do. Anyway, so that probably brings me to the end of my presentation. I hope you enjoyed, and I'm keen to hearing your feedback. Cheers.